Hello everybody. This video will cover the first free response question of the 2018 AP Physics 1 exam. 1. A spacecraft of mass m is in a clockwise circular orbit of radius r around Earth, as shown in the figure above. The mass of Earth is me. A. In the figure below, draw and label the forces, not components, that act on the spacecraft. Each force must be represented by a different, distinct arrow starting on and pointing away from the spacecraft. Well, here it says that the spacecraft is in circular orbit. So that means there's centripetal force. And in centripetal force, the net force is always pointing towards the center of rotation. So we can first draw the centripetal force with an arrow such as this. Well, now are there any other forces? Well, this is in space, so technically no. But you're probably wondering about the force of gravity, as it exists between two bodies. Well, the force of gravity is actually what keeps the spacecraft in orbit. The centripetal force is actually due to the force of gravity. So there's actually just one force, which is the centripetal force or the gravitational force, as they're the same thing. Part B, Part I. Derive an equation for the orbital period t of the spacecraft in terms of m, me, r, and physical constants as appropriate. If you need to draw anything other than what you have shown in Part A to assist in your solution, use the space below. Do not add anything in the figure in Part A. So we need to find the period, and the period is the time it takes for one revolution. Well, how should we approach this? Well, we know velocity is distance over time. And since the distance is one revolution is basically the circumference. So the distance is actually 2 pi r. The velocity is equal to 2 pi r over t. So now we need to solve for velocity in order to determine t. Perfectly. Centripetal force is the mass of the spacecraft times velocity squared over r. And since it's the same thing as the force of gravity, we can say this is equal to the universal constant g times the mass of the spacecraft times the mass of the Earth, all divided by radius squared. So we can lay the fractions out so that the equation looks like this, where we need to solve for velocity squared. We can multiply r to both sides and divide m on both sides, which would result in velocity squared equals g times me divided by r. Now we can rearrange this equation to say time squared is equal to 4 pi squared r squared divided by velocity squared. Now the reason why we squared the whole equation was since velocity is squared in this equation. It makes it simpler when we substitute them in. So now when we substitute, we see that time squared is equal to 4 pi squared r cubed divided by g times mass of Earth. And this would be our final answer. Now for the second part of B. A second spacecraft of mass 2m is placed in the circular orbit with the same radius r. Is the orbital period of the second spacecraft greater than, less than, or equal to the orbital period of the first spacecraft? Briefly explain your reasoning. Well, we're asked to compare the orbital periods of a change in mass. Let's take a look back at our equation from earlier. So from our equation found earlier, we see that the time squared is only dependent on the radius of the circular orbit, the universal constant g, and the mass of the Earth. Thus, we see that the period does not depend on the mass of the spacecraft itself, as there's no m in this equation, or little lowercase m. So a change in the mass of the spacecraft will have no effect on the period. Thus, we can cross off equal to as the correct answer. C. The first spacecraft is moved into a new circular orbit that has a radius greater than r, as shown in the figure below. Is the speed of the spacecraft in the new orbit greater than, less than, or equal to the original speed? Briefly explain your reasoning. So now we're asked to compare the speeds of the spacecraft. So we want an equation that can help us determine or calculate the velocity. Well, from our work earlier, we found that velocity squared is equal to g is equal to g times mass of Earth divided by r. Well, from our work earlier, we determined that velocity squared depends on the mass of the Earth and the radius of the circular orbit. So based on the equation, if radius increases, then the speed of the spacecraft would decrease, as they are inversely related. Thus, once the first spacecraft has been moved to a greater radius, that would decrease original speed. That means we can check off less than as the correct option. And that would be it for the first question of the 2018 AP Physics 1 free response.